pattern finding problem has really stumped quite a few top elementary school students. Actually, once you find the right breakthrough point, it's quite simple. First, let's take a look at this sequence of numbers 3, 8, 19, 34. The numbers keep increasing. So since we see the numbers are increasing, we usually try addition or multiplication. But which one works? Let's give it a try first. If we use addition, since the numbers keep increasing, from 3 to 8, you add 5. Okay, from 8 to 19, you add 11. And then from 19 to 34, you add 15. But there doesn't seem to be any pattern among these numbers, does there? So let's try multiplication instead. How many times do you have to multiply 3 to get 8? Well, it's not a nice, neat integer anyway. And from 8 to 19, you can't get there by multiplying by a whole number either, right? And it doesn't work for 19 to 34 either. So just looking at each number individually, it's pretty hard to find a pattern. So we can try to construct the numbers in a way that makes it easier to spot a pattern. Generally, how can we do this kind of construction? For example, subtract 1. Look, here it becomes 4 minus 1, and this 4 is an important breakthrough for finding the pattern. If you keep going, for example, this 8, how can we write it? 9 minus 1, and then, for example, the next one, 19, that's 20 minus 1. All right, the next number after that is 35 minus 1. Oh, so, since each individual number is carefully written as something minus 1, the very last number in the sequence can also be precisely written in the exact form of a number minus 1, just like all the others. Some students might ask, why is it always minus 1? Actually, this is a kind of number sense because when you work with 1, it's easier to come up with numbers that reveal a pattern. The more types of problems we see, the more naturally we'll be able to solve them. So we also need to keep building up our experience. Next, let me take a look at these numbers. 4, 9, 20, 35, and see what characteristics they have. First, I can try breaking these numbers down into the product of two numbers. For example, take the number 4. How can I break it down? Break it down into 2 times 2. Hey, that's 2 identical numbers. So what about 9? I can break it down into 3 times 3, which is also 2 identical numbers. So can I break down 20 in the same way? If I try to break it into 2 identical numbers, it's hard to spot a pattern, and we haven't learned this in elementary school. So in this case, since I can't find 2 exactly the same numbers, I'll look for 2 that are close to each other. So which 2 close numbers multiply to get 20? Is it 4 and 5? 20. All right, then for 35, which 2 close numbers multiply to get 35? Isn't it actually 5 multiplied by 7? And when we carefully write it out, let's observe 1, 2, 3, 4, 5. If we were to express this particular number as a mathematical product of 2 distinct numbers, who, in your considered opinion, do you believe the very first number in that product should logically be? See, 2, 3, 4, 5. So naturally, I write 6 next. Then, is there any pattern to the number that comes after it? Look, 2, 3, 5, 7. What kind of numbers are these? These are consecutive prime numbers. What's the next prime number after 7? It's 11. So actually, for the number above, isn't it just 6 times 11? It should be 66. But when you calculate the number inside the parentheses, you have to use 66 minus 1. And the result is, hey, 65. And with that, we've finished this problem. I suggest everyone give a little, like after watching, save it and watch it a couple more times. Otherwise, if you want to use such a handy method again, you might not be able to find it.